presentation, I'm going to take the opportunity to attempt, hang on, we're having some video issues, I believe. All right, okay. We're going to take the opportunity to try and present something that is pretty technical, and we are essentially going to try and deep dive at a level 400 on taking control of NVGRE with PowerShell. What does this really mean? We'll figure out as we dig into the session, but before we do that, I'll just give a little bit of background about myself. This is an ongoing part of a series of presentations I've been running, starting at level 100 and working their way up towards this presentation, which essentially is probably the single most technical of these that we have covered to date. In this particular presentation, we're going to focus specifically on the functionality of the NVGRE engine itself. Yeah, I actually got here for a change, Kev. In this particular case, we're not going to use any of the System Center tools, but rather go under the bonnet and figure out what's happening behind the scenes. Take a look at the actual configuration, what Hyper-V is doing, and specifically try and explain at a little bit lesser detail what are provider addresses, consumer addresses, and how they align to what are better known in the industry as both the data plane and the control plane. So with that, the first piece of background I will suggest is, if this stuff is brand new to you, the preview to this particular presentation was a level 200 white paper and presentation called Unraveling the Network with SCVMM, which introduces the theory of network virtualization, compares and contrasts it to the technologies that we're used to today, including standard VLAN technology and, of course, the newer PVLAN technology that has been introduced with the Hyper-V 2012/VMM 2012 product suites. We spent a little bit of time in that presentation talking about those two technologies, how they work and what they offer, before we dig in and compare and migrate that over to a software-defined network, and go into a little bit more detail at level 200 to talk about the packet flow and how that actually works in a software-defined network, and how Virtual Machine Manager embraces that technology. So if this stuff is over your head this afternoon and you find that you're getting lost, please ping me during the course of the meeting. We've got live updates happening on Link at the moment, and of course the recordings from Savision are available for download, and I have also some other material sitting on YouTube for the same type topics. So with that, I'm going to jump in. Hold on tight, because as I said, this stuff is going to get a little bit deep and technical, and do that pretty fast. But just to help us get a little bit acquainted to what's happening, what I'm going to introduce you to is a very simple network design, and we're going to compare software-defined networks to VPN technology, because in essence we are talking the same protocol stack. We are talking GRE. So essentially everything that we talk about when we deal with Microsoft software-defined technologies, it is network virtualized generic router encapsulation technology. VPNs have been using this same type theory for the last number of years, where we have IPsec/GRE tunnels. And really all this means is that we take a packet and we put it into another. So essentially I like to describe that as taking a piece of data, putting it into an envelope, handing the envelope to somebody else to actually transfer, and then when it gets to the destination on the far side, you pop open the envelope and you take out the original message. So it's simply encapsulating the data. So if we think about that for a moment in VPN technologies, there's one other thing I'd like to suggest, and that is the theory of what is a control plane versus what is a data plane. In a normal network today, where we've got routers, and if you think about this like your field offices and your headquarters, essentially what's happening is that we have the ability to route traffic from location A to location B. We have a static IP address. That IP address is routed or NATed to another IP address, or in most cases just allowed to pass through, sent across to the next hop, and essentially back into network. We're not doing essentially any encapsulation. We're just allowing that traffic through a set of traffic lights, a gateway to turn around and say that this initial traffic is allowed to move on to the next destination. With a VPN, that gets a little bit more complicated because we have to introduce the concept of the internet. And essentially what we see in that case is that the IP addresses that we have in our office, they're different from the IP addresses we have on the internet. Quite simply put, we have public IPs and private IPs, and essentially within our offices we all use the private IP. But to get from the office to the headquarters or from your home office to the data center, you have to basically take that piece of data and put it into a public IP pack so that we can actually send it across the internet. That process is not actually that complicated to do, and it's something that we've been doing for many, many years with the routing technology. Certainly for us as network administrators, as system administrators, this might be quite new, but from a network administrator, this is definitely old school stuff. And all that essentially is happening is the router is seeing the original packet with the source and the destination, and he's putting it into a new packet. So in the illustration here on step 2, I've basically made a new envelope, and I'm placing the original packet into that envelope. And with that packet in the envelope, I'm now in a position where I can turn around and I can send that across the internet. So the address that's paying attention here is the one on the outside of the envelope, the source and destination IP addresses of the 2 locations on the internet. When it makes it to the device on the far side, he simply opens up the envelope, pulls out the packet that's sitting in it, and delivers it to the destination machine. Now that's actually very simple. Not a whole lot of rocket science going on here. And essentially that's the grounding for what's going on in software-defined networks. Because, as I mentioned, GRE is the common denominator here, and we're actually using pretty much the exact same GRE protocol that we use in VPN. So if you get your head around what's happening in a VPN, then this is definitely not going to be much of a challenge for you. There are 1 or 2 minor changes, and this is where the RFCs, which is refer for content, or essentially where we take the actual design documents of what we're doing and put them out on the internet so everybody else can go back, review them, edit them, and essentially copy them so they can implement this technology in their own stacks. We've seen this already happening, certainly with Iron Networks, with Microsoft's own internal gateways, with stuff that we're getting from Cisco and the F5 solutions, and many others are starting to implement this technology. Arista, to mention one of the actual hardware manufacturers pretty close to delivering switches. These guys are all basically taking that RFC, taking that original GRE packet, and putting in the modifications that are needed for NV, adding those 2 extra letters, network virtualization. And really what that gives us is just a little bit of extra information taken from the original pack. So if I look at the drawing here, I'm starting off again with my normal source and destination IPs, but in this particular case I'm taking 1 or 2 more pieces of additional information and putting it in the envelope, stuff that I need to retain. Now, what are these and why do we care? Well, they're very easy answered questions, because if you go back and think about the VPN technology, it's a point-to-point. It's going from your headquarters to your field office. It's going from your desktop to your data center. It is a point-to-point connection. In the network virtualized world, however, we've got this concept of multi-tenancy, where essentially we need to know who is sending traffic to where. And in order for us to define that, we need to put some sort of an identifier against them. And that essentially is this VSID, Virtual Subnet ID. So essentially what we're saying is this is coming from Field Office 1 or Field Office 2. And if you think about this back in the theory of postal addresses and sort codes, every house has a post address. So therefore I always know that if the address is typed wrong, I still can check the postcode and I know where to deliver that particular message to. The VSID is quite similar. It basically turns around and says this is going to go to location Dublin or location Amsterdam or location Seattle, and then beyond that I need another little piece of information to help me define exactly where in Amsterdam, and that's essentially the MAC address, the actual MAC address of the network interface of our virtual machines. So by keeping these 2 little pieces of extra information, I now have enough details so when I take that encapsulated package out in the second host, not only do I know the source and IP and destination IP of where I'm going to, but I also know if I'm running in a multi-tenancy environment, which tenant, which virtual subnet do I need to deliver this to. And this is what enables us to allow the fact that multiple VMs sitting on the same host can all have the exact same IP address, but the fact that they're put into separate little farms or tenancy groups or cities, if you want to picture it in that mind. When it gets there at that point, you can then take it out of the envelope and deliver it automatically to the destination machine. And there you have it. Essentially, that is network virtualization. And if we look at the picture again for a moment, the only difference that we've done here from what we done originally with our VPN technology is we're dealing with two Hyper-V hosts, Hyper-V host A, Hyper-V host B, and we basically can have multiple tenancies sitting within that host, allowing us essentially to have that ability where if we wanted to have multiple VSIDs, so we could. Now, I promise not to make this presentation PowerPoint heavy, and we're going to spend a fair amount of time in the actual lab and try and make this stuff work. So before we do that, I'm going to introduce you to my lab. Now, my lab has been a little bit fussy today, I'll be quite up and honest. I'm running state-of-the-art technology, so if you want to do this at home, you're going to need to spend about 10 or 12,000 quid and buy some really good hardware. I wish. Honestly, I'm running this stuff on 6- and 7-year-old machines, and to prove that point, one of them decided this morning to fail the RAM in the box. So I've now got one machine who's got all of 2 gigs of RAM, yahoo, and another machine which has got all of 4 gigs of RAM. These are definitely not rocket science pieces of kit. PDC VM host 1 and PDC VM host 3, quite simply named as primary data center virtual machine host number 1 and host number 3. Host number 2, you might be asking what happened to it. Well, I said it was 6 years old. It decided not to start at all. So I'm kind of lucky to have number 3 around. Now, I've put 2 pieces of information onto each host, and in all honesty, I haven't even done that much. I've only put one piece, which is the IP address that we're going to manage the machine on. So essentially, the IP address that I RDP to in order to connect to that machine and do the work. So the management address. That's the same address that you guys will be putting in if you're trying to manage it through VMM, or if you're just RDPing to the machine, or you're doing PowerShell remoting. It is quite simply the management IP of that machine. Now we're going to assign another address a little bit later on, which is the provider address, and we'll talk a little bit about that as we go back and take a look again at the slides that we shown a few moments ago, where we talked about the theory of taking the traffic from the data plane and putting it into a packet and sending that packet across the internet. What I didn't tell you is that the IPs that we have in that data plane, those are really known as consumer addresses, or in better place, that is the data IP. It's the IP address that belongs on the data of the machine, the consumer address as Microsoft will call it. The address that we see when we're actually transferring information, either between our VM hosts or if we're doing it across a VPN, that is the control plane. That essentially is the packet that now controls where the destination traffic is going to be, where I'm sending my envelope that's got the data into it. So essentially, the address on the envelope is the address of the control plane. Now, Microsoft, again, diverged from the standard naming conventions and decided to call this one the provider address. So we will need to tell Hyper-V and the WNV, Windows Network Virtualization filter, what provider address he should use on each host. And that's something that we'll do as we go through the configurations. So with that piece of information in mind, we can certainly see that I've got 2 different IPs on each host. The only one that's defined right now is the management address. We'll program up the provider address in a moment. And one of the things you will notice here for the demonstration is I've kept the provider address on the same IP range as the management. Now, there's absolutely no requirement in doing that, and probably best practices would recommend that you don't, that you actually move your provider address into a different network segment, so essentially you can actually do all of the normal QoS, because this is the traffic that is going to pass between hosts for your virtual machines. So your management stack interface today, you're not sending live migration or storage traffic across, and the same would be true for the likes of provider traffic. And as we know now, provider traffic is that tunnel, it's that packet between the 2 hosts, so therefore you definitely don't want to be sending that across that same interface. You want to put that into a separate network, as much bandwidth as you possibly can, and you probably will want to think about doing things like calculating bandwidth and utilization on this particular network as well. But for the purposes of the demonstration and the fact that I've got a really small lab, I've bubbled it up and I'm using the same network segment. That's also going to make it easier for me to do a little bit of troubleshooting later on should we run into any issues, which is always possible. Now, I've got 2 tenants as well in the environment, and I've verged away from the colors of blue, red, green, and I'm going to introduce you to 2 tenants. Those are very well known, Contoso and Fabricam. And the thing that's kind of important here is that both Contoso and Fabricam are using the same IP address, 192.168.1./24. So essentially, we want to make sure that these 2 guys can exist on our environment, but using the same IP range. Now, there's absolutely nothing against stopping us having different IP ranges, but it makes it difficult to illustrate the power of software-defined networks. And with that theory, that same IP range could essentially be your on-premise address range. But again, from a demonstration perspective, it kind of dilutes the fact, because I can't show you things like IP conflict and the fact that IPs are insulated when I set them up in this environment. So essentially, we're looking at two customers. Both of them happen to be using the same IP range, and the only thing that I'm using to define the difference is the subnet ID. Remember back on the presentation drawing that we showed a few moments ago, where I had virtual subnet ID 5001, which happened to be that postcode to identify which the customer is. In my case, for Contoso, I'm going to call him 4501, and for Fabricam, we'll call him 4601. And again, we'll walk through the process of actually defining that. And the other piece of information that was kind of important to us was we had that MAC address so that we could actually find him within the postcode. So again, to make things really simple, I'm just going to go with a fixed MAC address so that things can actually be traceable. Okay. So, how does this stuff work? Well, really what we're looking at is the actual Hyper-V switch itself. So our hosts have the physical network interfaces connecting out onto the wire, the management interfaces. That connects up into the VM switch, and somewhere in the middle of the VM switch happens to be the network virtualization layer. The network virtualization layer is what makes all of this stuff work, so we need to turn that on first. Once we've turned that on, then we can take a look at what's happening on our virtual machines, our data plane, or as Microsoft call it, the consumer address. And on the other end of that plan, we've got the control plane, the provider address. So if you're still with me, these are the IPs that would have essentially have traveled across the internet, or in this case are going to travel across your data center, sending traffic between the virtual machines that are on different hosts. And finally, this thing called a lookup table, because we need to really tell the virtualization agent where the virtual machines are. So to do that, we have this concept of a lookup table. And again, we're going to define that, and this is one of the real reasons that you're going to use something like Virtual Machine Manager and not PowerShell for managing this stuff when we get it up and running. Because as you'll see as the demonstration moves on, this stuff gets really hairy really quick. Okay. With that, I think we're in good shape, and we're going to actually take a look at the very first step of the job, and that is flicking the switch and turning on the network virtualization generic router encapsulation functionality. It's a tongue twister, but it's actually very easy with a little bit of PowerShell, and the really good news is on the R2 environment, you don't even have to do this. It's already in the bag and sorted for us. So if Link is doing its piece, you should now be seeing the console of my first host. This particular host is, as I mentioned already, just running 2 or 3 virtual machines, Contoso 1, 2, and Fabricam 1. It has got nothing on it other than its own IP address. And as I mentioned in the design, it is going to be 172.21.10.201. What we're going to do now is we're going to actually flick the switch, and we're going to actually turn on the network virtualization feature. So the very first thing I'm going to do with a little bit of PowerShell is use one of the Hyper-V commands, if this thing will ever copy and paste for me, which is going to go out and grab the actual virtual switch. So within my variable, I should now have, I said these are very high-speed machines, so they run faster than I have. So I now have a link to my virtual switch. And just to prove that that's the same virtual switch, I'm just going to go over here to the virtual switch manager in the Hyper-V console, and I can see that the name of the switch should align to the switch that we have highlighted on the screen. Okay, these machines are slow, but this is horrendous. Okay, so while he's thinking about doing that, you'll trust me, and instead what I'm going to do is I'm going to basically take the next command, which is going to reference that switch and turn on the component for Microsoft's network virtualization. So the switch has actually rendered up here, Microsoft Network Adapter, and if I now paste in the command, which I just messed up. Okay, great. Try that one more time. We should be able to flick the switch and turn on network virtualization. Okay, this will take a moment, and we can see the process actually running. And if we're interested in seeing what has actually happened in the background, what we will do next is we'll try and do a get. So we've got different bindings essentially happening on the environment. The ones that we're working on is, as I said, the Microsoft Network Virtualization filter. So within the environment, we have set to true, essentially, the filter that is now responsible for doing the actual network virtualizations. So if we do a where enabled like we should see the ones that are all turned on, and if I take a look at the ones that are turned on, here I can see just above my mouse, network virtualization filter driver has now been switched on. So that's essentially all that we've done, and this is really the driving piece that's behind the logical network theory when we look at Virtual Machine Manager, getting that flicked to turn on. Okay, now we're going to need to do that on both of our hosts. So I'm just going to flick over as far as the second host, and I'm just going to repeat the same two PowerShell commands. Okay, now with that done, we've made it to the first phase of getting our systems ready. Now the next thing that we're going to have to do is basically take a look at the data plane. We want to actually talk about our virtual machines. And on the data plane, what we're going to do is we're going to set those static MAC addresses. So essentially, we'll set the MAC addresses that are on each of our virtual machines for Contoso and for Fabricam. Now, I've done a little bit of loop in the slide, but in the actual code I'm going to do, I'm going to name the actual virtual machine so that you can see essentially that I'm doing absolutely nothing really rocket science other than setting the virtual machine network adapter with a static MAC address for the name of that virtual machine. So in this case, I've got Contoso 3 on this host. So one of the things I'm going to do, though, is I'm not going to actually stop the virtual machine just to show you what happens. And if I try and assign the MAC address, he will come back and say, I'm sorry, you can't do this while the virtual machine is running. So risky as it is on a slow set of hosts, I'm now going to go ahead and paste in the command set, which will essentially stop my virtual machine, assign the static MAC address, and then bring back on that virtual machine again. And that could take a moment or two to run on this case. So I'll do the same on the other host as well. Again, for Contoso 1, Contoso 2, and Fabricam. And get those two guys. That's not what I want, machine. Copy and paste is definitely not cooperating with me very well. Okay, lovely stuff. So we should be seeing the Contoso VMs getting ready to shut down here, and if I switch over to the other node to see has this thing actually come to life, or has it? No, it actually didn't paste. Okay, and he's doing his job. Okay, so this is going to take a little bit of time on the host to actually complete. While we're waiting for that, one of the next things that we're going to need to do is we'll go back. We're going to need to actually set the subnet ID. So we talked about that again a little bit further back where we started looking at the drawings. We had that virtual subnet ID. So once again, our postcode for the city of Dublin, these are the virtual machines belonging to that area. In this particular case, we're going to assign the actual virtual subnet IDs that belong to both Contoso. So he is essentially tenant number 4501 and tenant number 4601. Now, if you're paying attention to these virtual subnet IDs actually go into the VLAN tag field of your virtual machine's network interface. And they start not at number 1, but at, well, can anybody actually guess what number they start at? If you've got an idea, paste it into the window. No, not at 1 or 0. So 0 in a VLAN word basically means promiscuous. Send traffic everywhere, we don't care. VLANs then start at 1 and work their whole way through to 4096. And from 4097 onwards, we basically have the subnet IDs. Now, onwards goes the whole way up as far as 16 million. So unlike VLANs, which top out at 4096 possible VLANs, virtual subnets or tenants is basically 16 to the power of 16 to the power of 2, which comes out somewhere in the region of about 16 million possible tenants can be hosted on a Hyper-V environment, all simultaneously. So that's a whole lot of actual virtual machines that can be sitting in there. Now, if I've done my job right, Contoso 2, Control 1. Of course, I started the machine and applied with the wrong one. You're an idiot, Damien. So I just hit turn off just to stop that virtual machine for a second, because of course I pasted the wrong PowerShell on this screen. And I'm going to pull that back down here. Tell him to set the network adapter, and yeah, great stuff. And then rather than wait for PowerShell, just start the thing up again. Okay, so copy and paste problem happened there. So on the far side, we can see that he has brought back up the control source and he's bringing down the Fabricam world. Okay, so far so good. So now, while we're doing that particular part of the process, let's now go ahead and assign the virtual subnet IDs to these virtual machines. So again, copying off the information and hopefully pasting it correctly this time. What we're doing at this point is that any machine that belongs to Contoso is going to be tagged to belong to tenant 4000 and 4501, and any machine belonging to Fabricam is going to be assigned to 4096. Now, this is very, very important, and we're going to take a closer look at this one on the Contoso machine, because the second we do that, we sort out our IP conflict issue. So switching over here, I'm not seeing anything in this interface, which is one of the reasons we're doing this thing in the PowerShell in the first place. Essentially, most of the stuff that happens in the network virtualization world happens behind the scenes. Virtual Machine Manager is a prime consideration of this. It doesn't tell you anything in any of the job logs of what he's doing. Hyper-V is a little bit similar in that it doesn't tell you a whole lot either. So really the only way to play with this stuff is with the PowerShell. So let's take a quick look and see, do we see anything over on this side. So taking Contoso 1. This side, actually, if I recall right, I haven't actually assigned the 2 subnet IDs yet. So let's take those 2, cancel this one for a moment. Gotta wait. So what we can check actually is we can check and see, do we get actually the static MAC addresses that we asked the machine to assign, because we should actually see those in the user interface. I do apologize about these machines. They're driving me nuts, so I appreciate that they're probably not helping your patients either. Click on advanced features and we might actually get to see some of this stuff. Yeah, Christmas. Santa Claus, please bring me faster machines. This one might actually run a little bit quicker. It does, great. So we'll use you for the demonstration. Take a look at the accessories. So here we can see when I switch over to this node, the MAC address that we assigned to Contoso 3 ended up with 03. So that's exactly what I wanted to happen. But what I didn't see changing was that VLAN identification piece. So just for argument's sake, just let's make sure we've done that right. So we'll assign it again for both Contoso and for both Fabricam. I'll cancel out, I'll come back in, and we'll take one more quick look to see on the properties of that virtual machine. And the reason I'm highlighting this is simply because this is when troubleshooting becomes a pain. Effectively, you see nothing. So if you are a person that works in the user interface, the beginning of your nightmare now begins, because everything that happens from this point forward isn't illustrated in the user interface, and that's really important to understand. Now, the other thing that I mentioned that was quite important is that we have essentially done the same idea as applying a VLAN. So if I can connect to my machine Fabricam and connect to my machine Contoso, one of the things that I want to do, if I just log in as the sysadmin or sysuser on these 2 machines, is I want to see what's happening from the perspective of IP addresses. Now, I'm going to take the 2 VLAN tags. So we basically said at the start that both Contoso and Fabricam are going to use the same IP range. And Contoso Node 1, in all its wisdom, is taking the IP address 192.168.1.11. And funny enough, Fabricam is using the exact same IP range. So if you put 2 machines on the same Hyper-V host with the same IP address, you get IP conflict straight away. That's essentially the very first thing that's going to happen. To fix the IP conflict, you normally will throw these 2 machines into 2 different VLANs. And the second you put them into 2 different VLANs, they're essentially isolated into 2 separate farms. If we take a look on this system, we should essentially be seeing the same scenario. So if I do ipconfig, this guy's still seeing a conflict, and he's basically went and put in an address resolution in here. So essentially he's gone with a 169 address rather than the 172 address I've told him to use. So let's put these two machines into two separate VLANs. So essentially tagging the two machines, Fabricam and Contoso, into two different groups. Now by doing that, we've basically said these are two different tenants. So very similar as VLANs. These are now sitting in two different tenancies in two different towns with two different postcodes. So with that, let's see if I can just get him to, I think probably the easiest way to do this is probably flick the actual network interface on the virtual machine. So let's open the network interface, go to the adapter settings, just disable it for a second. And if we re-enable it, hopefully he will actually assign the IP address that I requested and not that ARPA address. So with all the goodness in the world, guess what? I've got a 192 address. Okay, so this stuff, as I said, this is critical. You got to be well aware. It shows nowhere in the user interface, and this is the one piece that allows us to have multiple tenancies using the same IP address or addresses that you have brought in from your outside. So we've done that. Essentially, we've now put these virtual machines into their different groupings. So we're ready at this point to move on to the next phase. Essentially, it's important. We need to make sure that we have to do this on every host. So if you've got multiple hosts happening in the environment, make sure you tag your virtual machines. And again, this is something that Virtual Machine Manager or the Windows Azure portal will take care for you. It does this stuff in the background, so you don't see these virtual subnet IDs unless you start hitting with PowerShell. It's completely and utterly masked from you. Okay, so the next thing we want to take a look at is the control plane, the provider addresses. So we've got pretty good so far. We've got the network virtualization filter switched on. Because I switched on the network virtualization filter, I was able to essentially set a tag larger than 4097 to essentially put these virtual machines into their own little groups. And now I want to take a look at what's happening on the control plane. What am I going to do with the data that I need to get out of these virtual machines and send across the network? And more importantly, how do I set that stuff up? So, again, a little bit of PowerShell magic in here, and I'll try and explain what we're looking at. And we're going to go back as far as my first host. Now, in the first host, in this particular case, what we're going to do is we're going to go back and we're going to make a connection back to that same vSwitch. I could actually just use the existing vSwitch, so let me just check and see I haven't broken it. And I still have a reference to it, so I don't even need to redefine that thing. But what I am going to do is I'm basically going to see if I can figure out how can I connect to that module, that network virtualization module we turned on a few moments ago, so that I can actually set an IP address on it, that provider address. So PowerShell is the answer, and what we're going to do is we're going to basically make a handle essentially back to that same switch so that we can touch the provider address on it. Now I'm going to need to do this on both systems. So let me just repeat that same command over the far side, and just to show you that these are two different machines. The PA adapter is basically pointing at my team at this point. So I just touched the team interface, and the team is what's plugging into that network virtualization filter. So let me recap that for you for a second so you just see what we're talking about here. Switch back to that visual. The team, the LBFO team, plugs into the network virtualization filter in that graphic. So because we've made a connection to that team, I started with a switch, I used the switch to find the team. Now I've got a handle on the team. I'm going to use that team to talk to the network virtualization filter so I can actually assign the provider address that I'm going to use down on the control plane. Okay, so let's switch back again. And what we're going to do now is we're going to use a new PowerShell command, which is the network virtualization provider address command. And we're going to tell it that we're going to use the network interface that we just touched, the provider address interface, and we're going to set the provider address as 172.21.10.2.13 on VLAN 10.10. Okay, now as I mentioned, in a production environment you definitely will want to use different VLANs to take your VM traffic and put it elsewhere, but for my lab that isn't going to be the case. I'm going to keep everything on the same 172.21.10 address. So just before I paste that, let me just do this ipconfig. I've only got the address 172.21.10.203. Now if I take that and I run this next command, he He turns around and he tells me he's assigned the provider address. If I do this, what happens? There's another gotcha, because the provider address isn't actually presented to you. And what's worse, if I do this, ping 172.21.10.203, my local IP address, the management address, I can get a ping. But if I do the same to my provider address, 213, guess what I don't get? A ping. Troubleshooting, again, this one is really, really important to know. It sucks a lot and it can drive you absolutely nuts, but this is by design. You cannot see the provider addresses when you assign them unless you use the command get net provider address, net virtualization provider address. That is the only way to see that thing. So in 2012 R2, this stuff has been improved. It's still not perfect, but it's definitely one that you need to be aware of in production today. Now, I'm going to switch over as far as my first host, and I'm going to assign the provider address 211 on this particular host. And then I'm going to show you one more trick, because this one definitely makes no sense. So remember, I was unable to ping 172.21.10.201, which is, of course, my IP address of my management on the host. I'm not able to ping my provider address, but if all works, I am actually able to ping the provider address of the fire host. Now that's absolutely critical, because if this doesn't work, you're done. Nothing else would work if you cannot do this. So you need to be able to ping the provider address of the fire host. So the bottom line here is you cannot ping your own provider address. You cannot see your own provider address in an ipconfig command. You can only get it from the get net virtualization provider address. You, on the other hand, must be able to ping the provider address of the destination or any other host that's happening in your network. And as I mentioned before, those hosts can be on any other VLAN and can have their own gateways. So one of the command parameters for network virtualization provider address could be a gateway. So essentially, there's nothing saying that these provider addresses have to be even in the same network or in the same data center. They could potentially be up on Azure, and some of them could be potentially down on your premises. Just saying. Okay. So with that, we're definitely making some good progress here. We've got our provider addresses in place. The provider addresses are now pinging each other. We've caught the gotchas. So really, what have we left to do? Well, we need to get back as far as that data plane again, because we got one more thing to do with our customer addresses. And what we need to do is we need to get a GUID set up for our new customers. Now this is a little bit of a freaky one, to be completely honest about it. But essentially, not only do we use that virtual subnet ID to help us understand where these customers exist, but we also use one of these beautiful GUIDs to help us make sure everything is utterly and totally unique. So I'm going to go ahead and I'm going to actually paste in 4 lines. Those 4 lines are going to essentially create me 2 new GUIDs and then prompt those 2 GUIDs up on the screen so I can actually see them. So I've just created the first GUID, which is for Contoso. I'm highlighting it, selecting it, and I'm going to move over to the second node, and I'm going to put that GUID into the Contoso script on the far side. Now, why am I doing this? The GUIDs have to be unique in that no 2 tenants can have the same GUID. The same ID as no 2 tenants should really have the same virtual subnet ID. Now, saying that is probably not the most honest thing I could ever say. It is possible to use the same virtual subnet ID. It gets a lot more complicated where you have multiple network virtualization environments running on the same piece of wire simultaneously. When that happens, this is where the GUID kicks in, and he basically helps us to identify tenant ID 4005 from network 1 to tenant ID 4005 on network 2. You don't really want to go there. It's 16 million addresses in one provider space is more than enough for you to have no requirement to ever do this. But what you must do is you must utilize the same GUID for all of your hosts. So when you reference Contoso on Fabricam, you must always reference them with the same GUID ID. So essentially what I've done on the first host is I've gone ahead and I've created a new GUID, and I says Contoso is going to be this ID, Fabricam is going to be that ID. And when I go to the second host, I'm defining exactly the same thing. So now Contoso is going to use that same ID that I've defined on the first host, excuse me, CONT, Contoso, and if we can see, we've done the exact same on the first host. So now we've got those unique identifiers. Now, why do I need those? Well, I need those so that I can actually go ahead and assign essentially the Contoso ID to that subnet ID. So effectively it's making that link for me so that if I did decide to be completely mad and do multiple network virtualizations at the same time, that I can figure out that when I do talk about Contoso, this is the Contoso I'm referencing. But again, in reality, you're never ever going to do this. Now, the other thing that you need to do, which you don't need to do in the R2 version, is you need to define what IP range the customer is using in his in his VMs. In R2, you don't have to define this because with the virtual machine extensions, the integration components, it pulls this information out in the background privately and tells you nothing. But unfortunately, that's not the case in the RTM build, so you need to do that. So let's go ahead and set up the first one, and I'm going to go and do the same thing to set up the second one. Now, all we're doing here is basically saying that Contoso and Fabricam with this unique ID are using this particular postcode, and this is the IP range that they're using inside their network. Next hop is set to 0000, which basically means send everything to the default gateway. The default gateway doesn't exist. That's a topic that we'll talk about in another presentation where we'll actually talk about network virtualization gateways. But at that point in time, we'll change the network hop to be the actual gateway of the network virtualization gateway. But for now, we don't need to focus on that particular one. All we're doing essentially is making that GUID link back to what we've defined so far. And again, it's all in order for us to do that multi-tenancy. Now, I'm going to repeat that on my second host. So as you can notice, everything I'm doing on host 1, I am essentially repeating on host 2 because it is very, very important that both of those stay in sync. And the key piece of information there is I've already kept the same GUID ID. Now, he's telling me that I've got a problem here for Fabricam. And I'll tell you why I've got a problem for Fabricam, because Fabricam is shut down at the moment and not running because I ran out of RAM. So we'll just ignore that error. It's not important for the rest of the demonstration. But essentially, as you define your different tenants on the hosts, you need to register in what GUIDs they're going to be presenting on. Okay. We are definitely getting towards that point now where we can actually see this stuff come to life. So the good news is the only thing we've left to do now is the lookup tables. So we have essentially turned on network virtualization. We have basically educated the network virtualization agent of our tenants. We've told network virtualization what the subnet IDs are that the tenants will be utilizing. And we've gone as far as setting up a GUID, a unique global identifier for each tenant, Fabricam and Contoso. So network virtualization really knows, using that ID, who the different customers on our network are. What we need to do now, though, however, is tell network virtualization where they are. So we think about this again for a moment of the postman. We've taken the letter that's coming from my virtual machine. I'm going to send that letter down as far as the post office, network virtualization. He's going to put that in an envelope and he's going to send it to somewhere. The somewhere really was that information that was in that envelope originally to say, oh yeah, he needs to go to postcode 4501. So I need to tell the lookup table, you need to send that to the other host that happens to have that virtual machine. And that really is the address book. It's like in your telephone directory, you've got that book of numbers and who is where and what number to call. That's what we're doing here with the lookup tables. And this is where the stuff gets really, really ugly and why you want to use Virtual Machine Manager. So let me show you. Okay, deep breath, because this one is definitely not the prettiest in the world. So what we're doing is we're basically saying we're putting a new record into the lookup for the virtual machine name Contoso 3. Contoso 3 lives in the virtual subnet 4501. He's got a consumer address, so the IP address of that virtual machine is 192.168.1.13. And he's sitting on the host who's got a provider address of 172.21.10.2.13. So what we're doing in very simple terms here is we're telling the network virtualization filter in great detail exactly where every single virtual machine is. So when I have to find traffic and send it to a virtual machine that's not on my host, he can quickly look up the table based on the subnet ID, the MAC address, the IP address of the virtual machine, or the GUID of that virtual machine, and figure out who I'm sending the traffic to, as I've highlighted in red. And remember, we've got two providers, 172.21.10.2.11 for host 1 and 2.13 for host 2. So we're basically saying Contoso 3 and Fabricam 2 are sitting on host 2 if I look at the provider addresses. So let's just see if that's the case. So I'm on 172.21.10.203, and if I switch over here on that particular machine, flick it, I have Contoso 3 and Fabricam 2 sitting on that machine. So you know what? We're not telling any lies. We're good citizens here, and that's exactly where things are. And if I look on the other one, I can see Contoso 1, Contoso 2, and Fabricam 1 are sitting essentially on the host that's got the IP address 211.211.211, which is me. Now, let's go ahead and put this stuff in. Now, this is probably the very last thing that we really need to do. So what we're going to do is we're going to tell them these are the VMs that are sitting on host 1. So let's inject them into your lookup table. And at the same time, let's take the VMs that are sitting on host 2 and inject them into the lookup table. Now, the lookup table, obviously, we need to do the same for the far side because traffic on the far side, so the virtual machine here, Contoso 3, he's going to want to actually send traffic back to the far side. And if we're going to demonstrate this, I need to get past this crap. So hang on 1 second and we'll get him to reboot properly, because otherwise I'm not going to demonstrate this thing actually works. So click reset and let's see if we can get back up to an actual console. While he's essentially going to launch Windows normally, good lad, while he's starting up, let's take the actual lookup table, and it's exactly the same lookup table. There is no difference. It is word for word, verbose for verbose, exactly the same as what I pasted on the other side, and I'm going to paste them in here. Now, with that done, we have network virtualization turned on, configured, and routing. Essentially, we've enough work done now at this point so that if Contoso 3 ever decides to boot up properly and not in that silly mode he's in, I should simply be able to try and ping him from a node that's on the other host. So if I was to do 192.168.1.11, that pings fine because guess what? That's me. .12 was Contoso 2. He pings fine, and well, why wouldn't he? He happens to be sitting on the exact same host. But Contoso 3, let's just check him. Just make sure he's up. And if network virtualization is not going to let me down and the demo gods are behaving the way they're supposed to, then I should get a ping back as well. And there we go. That's network virtualization. Now, what happens if you decide that you're going to be a really smart guy and you're going to move a virtual machine? Well, before we do that, let's take a look at Fabricam for a second, because we fixed our IP conflict issue that we had in Fabricam a few moments ago. But let's see what happens if I ask Fabricam to ping himself 192.168.1.11. Happy enough, he pings himself. What happens if I ping .12? Well, he pings out because guess what? I don't actually have a running 12 on either side. He's turned off. So what we are doing here is essentially we have taught the network virtualization filter that these are indeed completely different entities. Fabricam is a tenant of his own, needs to be completely isolated and kept away from everybody else, and the same for Contoso. Those guys are now well and truly isolated. We've done that flick somewhere back in step 2 when we put them into their 2 separate VLANs, and then as we move to step 3 and step 4, we basically taught the network virtualization filter where to go and find that destination machine. Now let's prove that for a second. Let's just assume that I screwed this thing up. I don't use bad language on a call, but let's see if we were to cancel that one and we do a get net virtualization lookup records, right? So there's my list of lookup records. How about we pipe those to remove net virtualization? Oh, holy crap, I'll be tabbing forever. So we try and do it like this. Virtualization lookup records. And then I just do a get one more time to see what I just done. Wipe them out. So essentially I have basically stopped telling the network virtualization filter where he needs to send traffic to. So let's go back to Contoso again for a second. And I'm going to go to Contoso 1. And on Contoso 1, let's do those pings again. He's able to ping 12 because he's on the same host. He's able to ping 11 because he's on the same host. But is he able to ping 13 anymore? No, he's not. because he doesn't know how to get there. But if you're paying attention, I deleted that on the other side. I deleted that on the destination host. So even though this machine has a lookup table, and if I check that lookup table just to be completely sure that I'm not going completely stir crazy, get net vert lookup records, I can certainly see that I have Fabricam 3, worried about Fabricam 3, I'm looking for Contoso 3. There's Contoso 3. I'm saying Contoso 3 with that IP address is sitting at that provider address. So he definitely knows what to do with it. But the guy on the far side, he doesn't know what to do with it when he opens the envelope, because he doesn't have that lookup table. So as a result, he says, this is rubbish, and I'm going to throw it in the bin. And of course, he logs that information. Not. So you don't have a clue. Unfortunately, behind the scenes, you won't see any of this thing. So I think at this point we've probably got just about the whole end-to-end scenario working. We've figured out how this stuff works, and we've built the environment from the ground up, building Fabricam and Contoso and showing you how to do a network virtualization solution. Now there's one thing I'll probably highlight, because if you're like me and you have your labs, the chances are you might have Virtual Machine Manager and a few other bits and pieces running around. Here's a word of warning. Virtual Machine Manager is a bad boy. Virtual Machine Manager manages network virtualization and manages it very well. But he also doesn't like you managing virtual machine or network virtualization. So if you happen to be using your hosts, you happen to have pushed out a network virtual machine manager agent to those hosts, and you decide that you want to repeat the demonstration I've done today using the PowerPoints and the scripts that I'll share, then be warned that Virtual Machine Manager will stand in the background and he will watch you add this stuff. And every 30 seconds he will come in and he says, I didn't do that, get rid of it, and delete it. And like a good guy, he will log it nowhere. So you will scratch your head and you say, what the hell did Damien do that I can't? And the answer is Virtual Machine Manager is wiping it out in the background. So if you do want to do this, turn off the Virtual Machine Manager agent and get rid of it, because it is your enemy in this case. So there you have it. That pretty much brings us to the end of the actual technical stuff. I hope I haven't completely blown your mind. I appreciate this is a very technical presentation. As I said, level 200 stuff is sitting on the Civision presentation at the start. If you want more information than this is covered in chapter 5 of the book Hyper-V Installation and Configuration. So essentially we've brought that chapter partially to life. And in the meantime, all I can say is please make sure you join the rest of the MVP Pro series and see lots more really technical good stuff. And thank you to everybody for joining today, and certainly to Carrie and for Travis for organising this session. If you have questions, guys, we're open mic or IM, please fire ahead. Any final questions, or does this stuff make sense, or is there some bits and pieces that's been bothering you guys? I'm sure there's a few of you thinking about the network virtualization gateway, so there's definitely a whole lot more stuff we'll do on that. I have a session that I've been working on which is going to cover that as well with PowerShell, so again showing Virtual Machine Manager to the side so we can see what's happening on the hoods. I'll post more details of that one probably in the next 3 or 4 weeks on the blog, and we'll schedule some time to demonstrate that. But please, by all means, come back and ping us, hit the blogs or hit us on Twitter. Gotta hit that damn thing. And we'll see what we can do to try get your head around this stuff. And once more, thank you for joining this afternoon's show.
Thanks, Damien. It was a great talk. And just for everyone, the recording will be posted on the blog site later this afternoon, so you can watch for that. And we'll also have his deck available so that you guys can review that if you'd like. So if we don't have any more questions, let's see. There is one question, Damien. Which parts will still be outstanding in R2?
Okay, well, of course, thank you, Matthew. That's a very good question. So I'm just going to swing back here very quickly, and I'll highlight the stuff that's important from the graphics perspective. So in R2, network virtualization is turned on by default, so step 1 you can skip. You do not need to deal with that issue moving forward. Step 2 that we dealt with was defining the data plane. Everything that happens in the data plane you still need to deal with, so the consumer addresses. What you don't need to deal with is assigning the IP addresses that the virtual machines in the data plane are using, because the network KVP's functionality of the integration component will get that out of your VMs, let that be Linux or Windows. As long as the KVP works, it will work. All of the stuff on the control plane must be still done. You control that. That's your data center, so that you got to deal with. And finally, the lookup tables, hence Virtual Machine Manager. You're going to need to still continue to use that. So there isn't a whole lot that you don't need to do. There's just 2 or 3 pieces that are fixed up, but everything else is still good old PowerShell or Virtual Machine Manager behind the scene. And as I said before, Virtual Machine Manager does not tell you what he's doing, so you won't see this stuff in the log. When you move machines, nothing will show up anywhere in the log. I hope that answers the question. Great, thank you, Matt. Fantastic. Any final ones before we cut up? I think that's us, Carrie. Thank you very much.
Thanks again, Damien.
No problem, and thank you all for joining today.
All right, bye.